As you can see, we are moving back to our regular math book, Eureka Math. We're done with our Go Math detour, but we're learning about the same topic. And today we're going to combine lessons 5.16 and 5.17. And your learning goal is I can draw trapezoids and parallelograms based on what you already know about their attributes and properties. That's actually a little bit redundant. Attributes and properties means the same thing. Okay. Right now, I want you to tell your partner, if you have a group of three, tell your group of three, what is a trapezoid and what is a parallelogram? Are they the same? Are they different? What's similar? What's different about them? Go. Trapezoids, as we learned yesterday, have at least one, so it's one or more, pairs of parallel lines. Okay, I'm just going to do that for shorthand. Whereas parallelograms have how many pairs? Exactly two pairs of parallel lines. Does it matter what kind of angles those lines make? Does it matter in this case if you're distinguishing between trapezoids and parallelograms? No. These 9 polygons that have 4 sides, what do we call them? Quadrilaterals. Very good. How many polygons do you have that have 5 sides? 2. Count them carefully. How many are there that have 5 sides? 2. What do we call them? Pentagons. Very good. How many polygons do you have that have 6 sides? 2. So you might want to look at the way you're sorting them. If I took a picture of your thing, make sure you sort it correctly. What do we call polygons that have 6 sides? Hexagons. Let's back up a little bit. What do we call polygons that have 3 sides? Triangles. Very good. Now, we talked about how polygons with 4 sides, 4 angles, and 4 vertices are called quadrilaterals. Good. But now that we had yesterday's math lesson already, we know that we could further sort those quadrilaterals, right, into more specific classifications, okay? So if I'm going to ask you, let's say I tell you your next challenge is to sort those, just the quadrilaterals, into 2 groups, trapezoids and non-trapezoids. Don't do it yet. You shouldn't be touching the tiles yet. Like, what are you going to be searching for to see which ones are trapezoids and which ones are non-trapezoids? Are you going to be looking for angles? No. What are you going to be looking for? Ani?
I like the parallel.
We're going to be looking for parallel lines. How many sets of parallel lines does a quadrilateral need to be put into the trapezoids category? How many pairs of parallel lines does it need? Everyone show me. At least? 1. Very good. Okay, see if you can classify or sort those quadrilaterals into 2 categories, trapezoids and non-trapezoids. Go. We can see here that the left-hand group, this side over here, is the trapezoids pile because they all have at least 1 pair of parallel lines. Everyone take a look at your trapezoids pile. You should see letter K, J, A, D, and B. In front of you, you have your 5 quadrilaterals that you further classified to show which ones are trapezoids. Remind me again, how did you know that these were trapezoids? You know they're trapezoids because they all have at least 1 pair of parallel lines. Very good. Now, how can we further group these trapezoids? Well, how many, let's take a look at one of them at a time. How many sets of parallel lines does this one have? 1, right? They are right here. These 2 lines are parallel. Are the other 2 lines parallel? No. So it only has 1 set of parallel lines. So let's put this one here. Okay, what about this one? How many sets of parallel lines does this one have? 2. Okay, because we can see that these lines are parallel and these lines are parallel. Do you see that? Yeah. Okay, so should it go into the same area as the first one or a different area? Different. Very good. Okay, so let's put it into its own stack here. What about this one? How many pairs of parallel lines does it have? 2. Okay, let's put it over here. What about this one? How many does it have? 2. Okay. And what about this one? 2. Go ahead and sort your trapezoids into 2 different areas. One area that has 2 sets of parallel lines and one that only has 1. As you learned yesterday, parallelograms have 2 pairs of parallel lines and trapezoids have at least 1. So these ones over here, are they trapezoids or parallelograms or both? Both. But we can call these parallelograms. Let me switch to a better writing tool. Very good. Now the group on the right, can we call them parallelograms? How come? How come they can't be called parallelograms? These are parallelograms. Because they only have one set of parallel lines. So what do we have to label them? Trapezoids. Very good. Okay. So are all trapezoids also parallelograms? Are all trapezoids also parallelograms? Is this trapezoid? Is this a trapezoid? Is it a parallelogram? So are all trapezoids also parallelograms? No. Are all parallelograms, are these guys also trapezoids? Yes. Because all of the quadrilaterals on the screen are trapezoids, but only these ones right here are parallelograms. So here are some example trapezoids, okay? First of all, how do we know that this is a trapezoid? Well, we know because there's one set of parallel lines. There's right there. Do you see that? Okay. And we can see that on each side of the parallel lines, there's one pair where one angle touches the parallel line right here, and this angle touches the parallel line right there. And what do those two add up to? 180 degrees when I combine those. Okay. Now what about over here? I have one angle touching the top parallel line and another angle touching the bottom parallel line, right? Do you see that? And what do they add up to? 180 degrees. Let's check another example. Okay. Do you see how 90, first of all, how do we know this is a trapezoid? Well, there's two pairs of parallel lines. Are these other two lines parallel? No. Okay, so there's just, one pair of parallel lines. Each pair of parallel lines will have one angle that's touching it as part of the 180 degrees. Okay, so if I didn't know that this one was 115 degrees, let's pretend we didn't know. Okay, if I know that over here this is 65 degrees, how can I find this missing angle? I can do 180 minus what? 65. What is 180 minus, what's 180 minus 60? 20. Then what's 25 minus, what's 20 minus 5? 115. Very good. And so that's the missing angle. Do you see that? Okay. So based on this, what do you notice about the angles inside a trapezoid? There are two pairs of angles that add up to 180. What's the total measurement of degrees inside? 360 degrees. Okay. So from that exercise, we can see when you connect diagonal vertices or opposite vertices, they bisect each other. I wouldn't say bisect. That means that bisect, the word bisect right here is a vocabulary word you need to know. And the word bisect means it cuts it exactly in half. That means when I connected this vertice and I connected this vertice, it made a midpoint. Yes? And the distance of that midpoint, it splits exactly those lines in half. All four of them. Does that make sense? So try that. Connect your opposite diagonals and see if those two sides are exactly the same. So once again, what do you notice about the angles inside a parallelogram? Well, we noticed a couple things. We noticed that opposite angles are the same. And then again, were there pairs of angles that add up to 180 degrees? Yeah, just like we noticed before. Only this time, you have two different pairs, or two different pairings, because you have how many sets of parallel lines? Two. Very good. Okay.